Amazon Web Services or AWS. Let us break it down and let us understand it in its layman terms. Amazon Web and Services. So Amazon is the organization that provides these web services. What is web? Let's say that literally every interaction that we do right now through the internet is only through the HTTP or the HTTPS protocol. And services, in the sense, everything is a web-based service. That means every service that Amazon Web Services has, let's say that it has 238 services right now. All of these services are being exposed on the HTTP and HTTPS protocol. So therefore, you can go ahead and access all of these services straight through the console by just interacting with the console that Amazon Web Services provides you with. And cloud computing is nothing but a set of servers or storage or databases or even a broad set of application services that are given to you over the internet. So for example, you can create a virtual machine. You can go ahead and add as much amount of storage as you would like. You can go ahead and store files. You can go ahead and create databases. You can have a MySQL database. You can have a PostgreSQL database. You can have a non-relational database. You can have relational databases. And you also have streaming services, a lot of different services that fall under the application layer of services. All of these can be accessed over the internet. And cloud service providers such as Amazon Web Services, or it can be Azure, which is by Microsoft, or it can be Google Cloud Platform. They themselves own and maintain all of these hardware in order to provide you these application services. So therefore, you don't need to worry about how do you take a look at the hardware, or how do you maintain and manage the hardware. All you need to worry about is the service that they are providing over that hardware, and how do you configure that service, and what would you need in order for you to host your web application, or what would you need in order to create a messaging based application, or what would you need in order to go ahead and create a chat bot based application, what would you need in order to go ahead and create AI and ML based applications, and so on. So Amazon Web Services offers reliable, scalable, inexpensive cloud computing services. Reliable in the sense they have their own SLA periods. They ensure that they follow a lot of different compliance programs, at least 20 to 25 different compliance programs for health related data and so on, as well as for payment card industry. They follow a lot of compliance programs. In that way, I can say for certain that they are very reliable, they are very secure. And when it comes to the scalable aspects, if at all, let's say, for example, that you have a Black Friday sale, and during this Black Friday sale, you would like an additional capacity in order to provide your services, which your application provides to the entire world. At that point of time, you can go ahead and ask for a specific capacity, and you are getting that capacity. Or let's say, based on your CPU utilization of your server, you can go ahead and ensure that you have a scaling policy that adds more instances or adds more virtual machines to a group. And when it comes to inexpensive cloud computing services, they have a really good pricing model wherein they have a hour-based billing model, they have a minute-based billing model, they have a second-based billing model, they also have a millisecond-based billing model for some of the services. So it's free to join, and you pay only for what you use. So let's move ahead. Why do we need AWS? Why do you need to even study AWS? I will talk about these two aspects. Why do you need AWS? Because of its different locations they have across the entire world. So they have around 24 different locations, out of which 2 locations are being used by government cloud agencies, and 2 locations are being used in China, wherein you need to be in China as using an ISP provider in China in order to access those 2 regions. But other than that, you have 20 regions that you will be able to use for yourself. You have automated multi-region backups. So you do this configuration only once. And again, why would you need multi-region backups? And what does this entail? Multi-region backups in the sense, let's say, for example, that you store a file in a region. So let's say, for example, you store a file in the Northern Virginia region, and you would like to replicate all of your data to Mumbai region. You do that configuration only once, and you set it in stone, and Amazon ensures that they do that replication for you on your behalf. So in that way, we have automated multi-region backups, which also ensures the next statement, which is called as streamlined disaster recovery. Let's say, for example, that the Northern Virginia region right now has a cyclone or an earthquake or a power outage, and the entire region is down. You will still be able to deliver all of your content to your customers from the Mumbai region because you thought about multi-region backups and disaster recovery. You have flexibility and scalability. Flexibility in the sense you have so many different options. You can choose and a virtual machine with just one virtual CPU, 1 GB of RAM, all the way up to 76 virtual CPUs, 512 GB of RAM. So that's a beast of a machine. So you have a lot of flexibility in order of choosing your operating system. You can choose Amazon's own Linux operating system, or you can go ahead with Red Hat Linux Enterprise. You can go with Ubuntu, you can go with CentOS, you can go with Kali Linux. There are so many different options that you get that gives the flexibility. And also talking about the breadth of services that Amazon Web Services has, you have 238 across services across the entire platform that you can use. So in that way, you have so many different options. You can choose to at least have 5 or 6 different services just for compute alone, but then you have to choose them accordingly based on your use case. You have scalability. Like I mentioned, if suppose there is a Black Friday sale and you would like 10 new servers for yourself, you can ask for these 10 new servers and automatically you're going to get those 10 new servers. Think about 10 years before, when the cloud computing was not that great, or let's say for example 15-20 years before, when you had to provision your own data center or provision your own servers in your organization. Think about how difficult that was. In order to even see returns for an organization, it was pretty tough. They were spending a lot for capital expenditure, but when you start moving into the cloud, you spend for operational expenditure for the current running costs rather than spending all the money upfront in order to provision servers. So when you move to the cloud, you trade capital expenditure to operational expenditure. And then you have automated scheduling, which is great because you have a server in a data center that you are using, and then you create your virtual machines, and then you can also choose as to which virtual machine you would like to have over which server and the different placement constraints and all that. So that kind of capability is also provided by Amazon Web Services. And like I mentioned, it's inexpensive in the nature that you have this pay-as-you-go pricing model. You have to pay on a monthly basis. You don't need to worry about your daily costs. You just have to pay your bill at the month end. So they have a hour-based billing model for virtual machines. They have minute-based billing model for some of the build services like code build. They have a second-based billing model for some of the services like AWS Lambda, or even some Linux EC2 instances are second-based billing model. And they have 100 millisecond based billing model for AWS Lambda. You also have really good security on the AWS side, and we will deep dive into security in the next 15 to 20 minutes. And I'll talk a lot about security, and you'll get a really good idea as to how secure AWS is. And AWS not only just is a standalone entity, it integrates with a lot of different third-party APIs. So you have Dynatrace, which is an APM monitoring platform, which is called as Application Performance Monitoring Platform. It is the leading APM tool in the market. It integrates seamlessly with AWS. You have Sumo Logic, you have New Relic, a lot of SaaS-based products in the market easily integrate with AWS. So it's just not studying only about AWS, you have to also study about all of the different third-party APIs. So now you know as to why do you go for AWS, but then why do you need to study AWS? The reason that you need to study AWS, from my experience, what I would say is for the last 3 years, a lot of job openings, man, a lot of job openings on the AWS and the cloud and the DevOps side. And I would highly encourage everyone at this point of time to at least take a look at what Amazon Web Services provides you with. But then if it's not your piece of cake, it's fine. But then just take a look at it, because you may be very interested with all of its services offerings. You may not need to know literally all of the services that they provide, but at least the services that suits your needs, which at least brings you one step closer to getting placed for college students. And for experienced candidates, it is an added advantage, because whatever technical skill set you do have right now, you will be improving those technical skill sets when you start moving into the cloud. Whatever you are able to do on a local environment, you can do that on a cloud-based environment. So this is the hot topic right now. A lot of job openings do have AWS or Azure, and literally every designation that I see on LinkedIn Jobs or Naukri Jobs, or even every single developer-based designation also includes the cloud. So you need to know AWS or Azure, even if you are going to be a developer in any organization. Okay, so let's move ahead. So many people ask this question, like, what is the difference between AWS and Azure or GCP, or how do they compare with each other? So this is a snapshot from 2018. I still haven't found the right snapshot for 2020. But then you can see over here that in 2018 itself, Amazon Web Services was taking the market. For the last 9 years, take it from me, for the last 9 years, they have won the award for the best infrastructure as service based platform. And you can see over here, it proves that we have 68% of applications that are running on Amazon Web Services, close to 55 to 58% on Microsoft Azure, and 19% on Google Cloud. So Gartner, it's an organization who go ahead and validate each and every cloud-based platform, and they stated that Amazon Web Services and Azure are more DevOps centric or infrastructure centric, whereas Google Cloud Platform is more developer centric. And a lot of companies, not just one cloud platform would suit your needs, but more than one cloud platform would suit your needs. So you shouldn't be a person who just sticks to one cloud platform. You should be a person who knows at least 2 or 3 cloud-based platforms. And Gartner also stated that a lot of companies use GCP as a strategic alternative if their businesses compete. So let's say, for example, Amazon as a company is in a biopharma domain, let's say, for example, and then you as a person who's working for an organization, who's working for a client, is in the biopharma domain. So you would probably not choose Amazon Web Services because your businesses compete. So you would probably go for some other cloud-based platform by a different vendor, whose business does not compete with yours. So some of the benefits of cloud computing, we have 4 major benefits that we are going to cover over here. You have agility. You get that speed in the market. Think about 15, 20 years before, when you had to develop your own product and host it. It used to take a lot of time, man. You had to provision your servers and all that. It used to take a lot of time. Even for you to see returns, you didn't have that many startups in 2002, 2003, or 2005. You have a lot of startups right now. There are companies that are born and brought up in the cloud. And that gives them the advantage of agility. That gives them the advantage of speed over the other people in the market. So one classic example is, if you would like to provision a server on AWS, you get that server's capacity within the span of 30 seconds. Think about provisioning your own on-premise environment. 3 months? Let's go on to the next advantage, elasticity. So you had to over-provision your infrastructure in order to ensure that you had enough capacity to handle your business operations. But right now, if you would require just only 1 GB of RAM and 1 virtual CPU to host your application, you get 1 GB of RAM, 1 virtual CPU. You don't need to over-provision your servers. In that way, you only need to spend for ongoing cost, like I mentioned before, trading capital expenditure to operational expenditure. So knowing your capacity and provisioning only that capacity, not going ahead and provisioning a very big capacity in order to ensure that probably one day in the future you're going to reach that capacity. That's not the right way to do it in the cloud. Best practice is to always think about what kind of capacity you would like and go ahead and provision only that capacity. That is called as elasticity. You can deploy globally in minutes. You can use one of the features of Amazon Web Services, which we'll be studying later, which is called as edge locations. And they have set up 216 edge locations across the entire world. And you can use these edge locations as caching servers in order to deploy your application globally within the span of 6 minutes. They have done a lot of performance optimization in regards to that. So that is one more greater advantage, because if a person is going ahead and accessing your application from Northern Virginia and a person who's going to access your application from Mumbai, both of them will have very low latency because you have deployed your application globally in minutes using edge locations, especially those 216 caching servers. And again, benefits of cloud computing: cost savings. You trade capital expenditure for variable expense and you pay only for what you consume, which is pay-as-you-go pricing model, which is excellent. So you don't need to worry about provisioning data centers or physical servers and all that. You just need to hire the right people in your organization in order to manage and provision your capacity on the cloud, specific to your application's demands, not over provision. So let's move on to the cloud service models. These are things that a lot of people already know, but then I will talk about some cloud service models that are in the future, probably in the last 3 years that they have come out. A lot of people know about software as a service, platform as a service, infrastructure as a service. But not that many people are aware about container as a service, functions as a service, disaster recovery as a service, database as a service. These are things that have come out in the last 3-4 years when containers and as well as functions came into play. And it was really amazing to see every cloud-based platform provide examples on, provide services on these new cloud service models. So container as a service, AWS has a service called as Elastic Container Service. They have a service called as Elastic Kubernetes Service. For functions as a service, AWS has a service called as Lambda. Its equivalent on the Azure platform is Azure Functions. Its equivalent in the Google Cloud platform is called as Google Functions or Cloud Functions, I believe. Yeah, so literally every cloud-based platform right now is investing a lot in terms of container as a service, functions as a service, database as a service, and Cloud Endure. If you have heard about that product, Cloud Endure as a product allows you to do disaster recovery as a service. But now let's take a look at how this compares with your on-premise infrastructure. What is the delegation of the cloud provider and what is your responsibility? So when it comes to on-premise infrastructure, everything you have to manage right from the networking stack all the way up to your application stack. Networking, storage, servers, the virtualization layer, the operating system that you give for each and every virtualized machine, your middleware, your runtime, your data, as well as your applications. Everything is your headache when you go with an on-premise infrastructure. But now, with the infrastructure as a service-based cloud service model, the networking, storage, servers, and virtualization layer, even the patching and the updating of the servers, patching and the updating of the virtualization layer, everything is being taken care of by the cloud provider, whereas your operating system, your middleware, your runtime, your data, as well as your applications, all of these are your responsibilities. So that means patching and updating your operating system is your responsibility. Installing your runtimes is your responsibility. Storing and encrypting and having a secure data storage for your application data is your responsibility. Hosting your applications is your responsibility. But now when you move on to the platform as a service-based cloud service model, everything from the networking towards the runtime stack is being taken care of by the cloud provider. A classic example for this is Elastic Beanstalk and Google App Engine on the Google Cloud platform and Amazon Web Services platform. The reason is because all you need to do in platform as a service is you have to give your application artifact. It can be a jar file for a Java application. It can be a var file. It can also be a zip file. You have to just provide this artifact and automatically it's going to manage and maintain those servers for you, where you need to just worry about building, testing, and deploying your applications. So that means you are only responsible for the data and the applications under platform as a service-based cloud service model. And when it comes to software as a service, everyone loves SaaS. The reason is because you don't need to worry about anything. A classic example for this is Salesforce. Another example, Dynatrace. Another example, Sumo Logic. Another example, Neuralink. So many different SaaS-based products. Even Amazon Web Services on their services offering themselves have a SaaS-based product called as QuickSight for visualization of data and for business analytics and data analytics in terms of visualization. So when it comes to software as a service, everything is being taken care of by the cloud provider, but then you have to know as to how to configure that software in order to, satisfy your needs for your organization. You must pay for a licensing cost. Dropbox is a SaaS-based platform. Google all of the app services under Google. Let's say, for example, you're using Google Drive, you're using Google Sheets, Google Docs. All of these are SaaS-based products. Microsoft Office 365 SaaS-based products. So all of these are, again, SaaS-based products, but then you should know as to how to configure them, but you don't need to worry about how it's working underneath in the background. A classic example is Salesforce uses Amazon Web Services in the background. Dropbox uses Amazon S3 as its backend store. A little bit more detail in terms of the examples. So Google G Suite, Microsoft Office 365, Dropbox, these are all SaaS-based products. So the vendor who provides that product controls the entire computing stack and just gives you access through a web-based browser. The applications run on the cloud and you pay for a license period, and then you do get free access for a limited time period so that you can try out that product. When it comes to platform as a service, all you need to worry about is just developing, testing, and organizing your or deploying your applications onto the cloud. But you don't need to worry about the underlying infrastructure that is being provisioned because the cloud provider takes care of that. Classic example for that, Google App Engine on the Google Cloud Platform, and AWS Elastic Beanstalk on the Amazon Web Services platform. Now, when it comes to infrastructure as a service, literally everything is your headache except for the virtualization layer and below, which is taken care of by the cloud provider. And Amazon Web Services for the last 9 years have been taking the reins, have been on top for infrastructure as a service based cloud computing platform, closely followed by Azure and Google Compute or Google Cloud Platform. Okay. So a small intro into how Amazon Web Services started off. So in 2003, they designed a documentation and two people presented a paper on how internal architecture of Amazon is going to be and how can we provide it as a public cloud offering. In the year 2004, SQS, their first service, which is called as Simple Queue Service. So it had two variants. It had a standard queue, it had a FIFO queue or a first in, first out queue. It was used to decouple your entire infrastructure and go ahead and store messages onto it. That was their first service that came out. In the year 2006, officially, Amazon Web Services was launched. In the year 2010, 180,000 developers were working on the Amazon Web Services platform. Think about it. 180,000 developers. Literally every day working on this platform, making it what it is today. In the year 2010, Amazon.com, their shopping website, moved into Amazon Web Services. In the year 2011, there was a first problem. In the year 2012, the reInvent conference was started. And if at all you do get the chance to go all the way to US, probably to Las Vegas, you will be able to see this conference live. It's a 5-day event. It's an amazing event. You can learn a lot from this event. In the year 2013, certifications were launched. Certifications are great. I will talk about it in the next few slides. In the year 2014, they committed towards achieving 100% renewable energy. In the year 2015, the revenue was $6 billion and it was increasing 30% year on year. In the year 2016, it was $13 million. And from the year 2016 onwards, they started working towards a lot of artificial intelligence and machine learning based services, which was pretty cool. And now they have a diverse set of ML and AI services. And they finally launched their machine learning specialty certification in the year 2018. So this is a brief history about Amazon Web Services and how they started. Now let's take a look at all of the different services that they offer. So Amazon Web Services have split up their certifications into 4 different categories. You have a foundational level that was introduced in 2018. You have associate level, you have professional and specialty level. So the foundation level has an exam called as Amazon Web Services Cloud Practitioner exam, which is the most basic exam in order for you to get started. I would highly encourage everyone to get started with this exam. And then on the associate tier, they have 3 exams. You have Solutions Architect Associate, Developer Associate, SysOps Administrator Associate. And on the professional level, they have Solutions Architect Professional straight over the Associate one. And for the DevOps Professional, it's a combination of both SysOps Administrator Associate and Developer Associate. And take it from me, the professional exams are really difficult, man. Take it from me. It's very difficult. But then every single day, if you spend 1 hour for yourself, other than whatever you're doing right now, irrespective of whether you are a professor or irrespective of whether you are working in the industry, spend 1 hour every day for yourself to study that is something that is current and new. Because we all know right now that our education system is outdated. Probably with the new education rules that came out 2 days before or a day before, something would change. But then every single day you have to think to yourself, study something current and new for 1 hour every day for yourself. That's how you catch up to where the market is right now. That's how you get the most premium salary in the market. And when it comes to the specialty tier, based on every single domain, they have split up their exams. So if you're a person who is inclined towards doing a lot of database related workloads, you have a database specialty exam that they brought out this year on March 20th. You have data analytics specialty, which was previously called as big data specialty. You have Alexa skill builder. If you're a person who loves working with Alexa skills, as well as developing applications for the Alexa device, you can go ahead and take a look at that specific certification. If you're a person who is inclined towards doing AI, ML, supervised learning, unsupervised learning, a lot of things, reinforcement learning and so on, you can always take a look at all of the different service offerings by Amazon Web Services for ML. If you're a person who is into cloud security, or you're a person who is very inclined towards doing a lot of penetration testing, cyber security and all of those things, you can have cloud security in your arsenal. In terms of marketing yourself, it will be really good. And finally, if you're a person who is really good at networking, you're a person who does a lot of VPN setups, you're a person who does BGP protocol, you're a person who takes a look at all of the different OSI layers and do networking on a daily basis, like work with switches, with routers and all that. And you can take a look at how all of these configurations are done on the cloud. You can always go for the advanced networking specialty exam. So again, what benefits do a certification give you, and what benefits does a certification give an organization? So a benefit that you are getting through a certification is that if you are a college fresher, or if you're a person in the third year of college, you will be able to land a job with a really good organization, provided you know what you're doing, provided you know all of the different configurations that you have studied, and you don't do the certification just because everyone else is doing it. You're doing a certification because you want to do it. And then the advantage that an organization gets because you're doing a certification is because they will be able to go ahead and market you on a much higher level, and they'll be able to get a lot of projects into the organization because they have so many certified individuals. So that is the advantage that you get out of doing certifications. And I would highly encourage everyone to do it at the start of their career, or even if you are a 15-20 years experienced person, I would highly encourage you to get started right now, because learning is a continuous process. I spend 14 hours every day. I just sleep for 6 hours. That's my schedule. I ensure that literally every day, other than the office work, I spend 1 hour every day for myself. So I'm just putting it out there right now that I want you guys to also do that and be as motivated and as positive as possible. And this is a small depiction of the Gartner's Magic Quadrant from 2019. It's stated that Amazon Web Services has been named for the 9th consecutive year as the cloud service platform for infrastructure as a service. And every year, they launch at least 1,400 to 1,600 small configurations to the platform every year. And recently, Google Cloud Platform in the year 2019 moved from the visionary space to the leader space. But then you can see over here, you have a lot of niche players, a lot of small companies that are also providing great cloud computing services, like Alibaba Cloud. Major market is in China by Jack Ma. You have Oracle Cloud, you have IBM Cloud. But then in the year 2017, there were a lot of small companies, but then every small company has been bought by these big giants, either by Amazon Web Services or Microsoft or by Google. It's pretty amazing that they are able to get all of these different small cloud-based platforms and integrate it into their own platform. A small fun fact over here is that a lot of people who would have heard about OpenShift, Amazon and Red Hat has put up a merger right now, and they are going to go ahead and bring out OpenShift on AWS, which is great. So like this, they put a lot of great combinations, or I would say great partnerships. Another class example for a partnership is that Amazon Web Services and Microsoft, if suppose a person goes to them and asks them, can you give me a new service? Amazon Web Services and Microsoft are like, let me get a company that is providing that service and let me acquire that company. Whereas Google is like, I'm going to develop everything in-house. I'm going to do all of the development by myself, and I'm going to bring out that service. So in that way, you may see that Google is a little behind, but then Amazon Web Services has a lot of market share and a lot of job opportunities. So now let's move on to the next slide. So now, like I mentioned at the start, I never spoke about the security aspects, and now you have to be very intuitive, and you have to listen very carefully the next few lines that I say, because I will be talking a lot about security aspects in terms of the shared responsibility model. So shared responsibility model talks about two people's responsibility over here. One is your responsibility, because you are responsible for security in the cloud, which means you are using the cloud-based platform that Amazon provides you with. And then Amazon is also responsible for some of these security aspects. That is called a security of the cloud. So first, let's talk about security of the cloud, and let's take a look at the global infrastructure of the three major components that they have. So you have regions, you have availability zones, and you have edge locations. So regions, like I mentioned before, you have 24 regions, out of which these are geographical regions where they have set up their data centers. They have split up these regions into availability zones, but then they have 24 regions, out of which 2 regions are for government cloud agencies. FBI, Pentagon can probably be using that. They have their own separate backup power lines and their own separate internet lines, separate generators. They have separate cooling facilities and all that. But when it comes to the other 2 regions that are in China, unless and until you are in China and you are using a valid ISP provider in China, you will not be able to go ahead and access the China regions. But if you're, a normal person who would like to deploy infrastructure onto the AWS platform, you can always work with 20 other regions that are available for you. And when it comes to availability zones, each and every region consists of one or more availability zones, wherein each and every availability zone consists of one or more data centers. I'll repeat that. Listen very carefully. Every region consists of one or more availability zones, and every availability zone consists of one or more data centers. And there is one very nice fact about availability zones is that each and every availability zone is splitted across with a distance of at least 100 miles. The reason is because if suppose there is a natural disaster or an earthquake or something like that that happens in the first availability zone, the other availability zone is not affected. So if you ensure that your application is being served from both the availability zones and you are architecting for high availability, which means that even if one availability zone goes down, you will still be able to serve your end users from another availability zone. So this is called as a highly available architecture. In regards to that, you also get zero downtime for your application. So that's an amazing concept. And at the same time, every availability zone is interconnected by fiber optic cables in order to ensure that you will be able to do synchronous replication. So let's say, for example, you have a database in one availability zone and you have a database replica or a standby database in another availability zone. There is synchronous replication that is happening, which means every transaction that you write to your primary availability zone, which is in one, which is obviously in the same region, automatically that data is being replicated to the second database in the second availability zone, that standby database, in order to ensure that you have this synchronous replication across your database. And that is possible because of the network that Amazon Web Services has set up in order to connect these availability zones. And then finally, you have edge locations. So edge locations are these caching servers. So the best way to depict this is, let's say, for example, that you are going ahead and hosting an application out of Northern Virginia, and then a user in Mumbai is accessing your application. So for the first request, the user will request for the object from the Northern Virginia region. But then for the subsequent requests, if you are utilizing edge locations, all of the data is only going to come from an edge location that is closer to the user. In that way, you get low latency. In that way, you reduce the burden on your origin server from where you're hosting your application. So you have these 216 caching servers that they have set up. You have one in Kolkata also that they recently set up in India. So over these three major components of the global infrastructure, they have four major components called as compute, storage, database, and networking. And literally every service of the AWS ecosystem falls under these four major components. So that means AWS is responsible for the security of the cloud, which means they will have to worry about securing this entire infrastructure in terms of having security personnel, multiple backup power lines, multiple internet lines, iris scanners, fingerprint scanners, abstraction in terms of dividing all of their data centers in layers and ensuring that every individual has access only to what they need. You have so many different security features that they are doing. And again, whenever they are decommissioning hard disks, they use the NIST standard. So in one of the reInvent conferences, they showed a picture of sand in the sense whatever you find in the beach. So ultimately it was a hard disk, it seems. So that's how important they think about security of the cloud in terms of their data center security. You can always take a look at all of these data center security in terms of YouTube videos. But now let's move on to security in the cloud, which is our responsibility. All the things that we are responsible for, and the topmost priority for us is customer data. If you are not secure about your customer data, you'll be chucked out of your organization for even in the first day or the second day for sure. Because customer data is top priority. It has to be private. It has to be encrypted at rest. It has to be encrypted in transit. No one should be able to access your customer data other than your applications. Probably just one person who is a database administrator could possibly access your customer data, but then it should be on a very granular level access in terms of no one can delete, but only access it. And then you're also responsible for all of the platforms and the applications that you host. You are responsible for identity and access management, in the sense you are responsible for the 3A model. You are responsible for authentication. You are responsible for authorization. You are responsible for auditing. Authentication in the sense who can log in. Authorization in the sense what kind of access do they have. Auditing in the sense If at all they do something, do you have a log trail? Do you have a trail of what that person did? That is called as auditing. So you are responsible for setting these things up. You are responsible for patching and updating the operating system in terms of infrastructure as a service based cloud service model. You are responsible for all of the network and the firewall configurations. What port would you like to provide access on? What port would you like to deny access on? Which IP address would you like to allow access? Which IP address you are going to deny access? You are also responsible for server-side encryption, probably by creating your own keys using the key management service, creating a symmetric key or an asymmetric key for encryption and for decryption. You are responsible for that. Encrypting your data at rest using these keys. Encryption of data in transit by providing or provisioning SSL certificates. So that is called as network traffic protection. Ensuring that all of your log files have protection in terms of enabling log file validation so that you can even find out if anyone tampered with your log files. So all of these things are your responsibility. That's the reason why, you are responsible for security in the cloud, and AWS is responsible for security of the cloud. So I hope you got a really good idea in terms of the shared responsibility model. This is pivotal for you to crossing your cloud practitioner exam. So like I mentioned, in terms of region, this is a pretty outdated slide. It's 24 geographical regions, and it's split across these geographic regions, in the sense it's split across Northern America, South America, Europe, Asia Pacific, and they recently released Middle East for Bahrain. And again, for Asia Pacific is where Mumbai is, where Singapore is. For Northern America, you have Northern Virginia, you have Oregon, you have Ohio, you have Northern California. You have South America, you have Europe, where you have London, and all of those different regions. I may not remember all of the 20 regions by heart, but then I can show it to you on the console a little bit later. Now, when it comes to availability zones, like I mentioned, each availability zone can be multiple data centers, typically 3. And again, they are fully isolated partitions, which means they have their own power infrastructure. And these availability zones are physically separated by a meaningful distance, 100 kilometers or 60 miles. And the reason is because if suppose one availability zone is affected and that availability zone goes down, you can always ensure that you have deployed your application across multiple availability zones in order to get high availability and fault tolerant architecture. And like I also mentioned, availability zones have high bandwidth, low latency network, and fully redundant fiber cable that are being provisioned, which provides you with this low latency access and also allows you to do synchronous replication. It's very powerful, and this partitioning of availability zones makes it easy. And again, if your application is partitioned across multiple availability zones, like I mentioned, companies are better isolated and protected from any kind of issues such as lightning strikes or tornadoes or earthquakes and so on. So you can use Amazon S3 as a service for storing all of your files, which is by default replicated across multiple availability zones, which means across multiple data centers within those availability zones, in order to provide you the 11 nines durability factor. So all of these different services you have to choose based on what you want in order to satisfy a client's requirement or your business needs, and also ensure that you have a high availability architecture or a fault tolerant architecture, and also ensure that you've taken into account disaster recovery. Okay. So when it comes to edge locations, there are 216 points of presence, 205 edge locations, and 11 regional edge caches, which are much bigger edge locations set up in 84 cities across 42 countries. And some of the security aspects that are given to you through edge locations are, you get protection against network and application layer attacks. You can get protection against cross-site scripting, SQL injection, bad bot scraping, HTTP flood attacks. Even you can protect yourself from people who are accessing your website from behind a VPN. That is also possible. You do get SSL and TLS encryption in transit. You get HTTPS by default, but you can also provision your own SSL certificates through Amazon Certificate Manager, which gives you SSL certificates, and then you can associate it with your CloudFront distribution, or you can associate it with your load balancer in order to ensure that you get HTTPS protocol in transit or security in transit. You can also ensure that you have access control, wherein you can specify that I don't want one particular country to access my application. I don't want some other country to access my application. You can always do that using access control. And finally, all of these edge locations on an infrastructure level follow these compliance programs, a lot of different compliance programs. HIPAA for health related data, PCI DSS level 1 for payment card industry data security standard, and world known ISO standards. So this is a map of all of the different edge locations. Obviously, you can't plot 216 edge locations over here. So therefore, we have the pink dots specifying multiple edge locations, the blue dots mentioning edge locations, and the orange ones mentioning regional edge caches, or the bigger edge locations that are available in those areas. So now when you get started with AWS, a lot of people ask this question as to, do I have a free period of time that I can explore AWS and still not pay a bill and so on? Obviously, that's the reason why AWS has brought out the free tier. With the free tier, I'll show you this as to how to access this. You get 12 months of access, but you have to stick to the limits that they provide you. For example, you have one virtual CPU, 1 GB of RAM, which is called as a T2 micro instance, that you will be able to work for 750 hours every month. So even if you keep it running 24/7, you will not reach the 750 hours. So always stick to the limits, and you can always find all of these limits by just going to this link, or aws.com/free, which talks about free tier. And now a lot of people are asking as to, how do you create an AWS account? How do I do it the right way? So in order to create a new AWS account, you have to follow these specific steps. You need to go to aws.com, click on sign up for an AWS account, and then go ahead and enter your email address, your password, your username. Choose whether it's going to be a personal or a business AWS account. And once you have chosen that, you have to enter your address details and your card details. Once you enter your card details, ensure that you use a credit card, because right now they don't support debit cards for some banks. So ensure that you use credit card. And once you pay the 2 rupees amount, and then you come back to the same screen after entering your OTP, it's going to redirect you to a mobile verification page. And you have to enter a 4-digit number that comes to your mobile phone. Once you enter that 4-digit number, it is going to ask you for your preference, which support plan you're going to use. You can go with the basic free support plan, but they also support developer, business, and enterprise support plans. But you can always go with the basic free support plan. Once you go with the basic free support plan, it's going to ask you some personalization questions in terms of what kind of designation or what is your interest in terms of using AWS and all that. And then you will get a mail from AWS stating that your account is activated within the hour, and then you can get started working with your AWS account. So these are all the steps that you have to follow in order to get yourself an AWS account. So let me open up the browser and let me show you the free tier. So let me go back to Google Chrome. So you should be able to see, let me go ahead and type aws.com/free. And when you type aws.com/free, sorry, I just put fees. Yeah. So this is the AWS free tier page. You guys should be able to see this in a second. Yep, this is the AWS free tier page. You can see over here, you can access at least 75 AWS products. There are some products that are always free with 12 months of free usage. You can see all of these free tier services that you can use. You can get 750 hours of a virtual machine, 750 hours of a database server of a specific capacity, 5 GB of storage on Amazon S3. Fun fact, I used to go ahead and provide all of my movies to my twin brother who is in Japan. I used to upload my movies to S3, and he used to download the movies from S3. I used to download it via torrent, and then he used to go ahead and download it from S3. So that's the way I used to share movies with my twin brother. So it's an amazing way. You can also even download all of the files from S3 as torrent files. So that's really great. All of the different features that they provide is huge, man. And you will fall in love with this platform once you start working with it. It's very easy to use. Always look out for a nav bar on the left side. Look out for a nav bar on the top. All of your configurations are there. So you can take a look at all of these different services split across all of these different product categories. You can take a look at all of these services and always stick to the limits. So let me sign into the console and let me show you what are the different services that AWS has. And then we will wrap up the session and we will go for questions. So I'm logging in as the root user. This is one of the accounts that I've been using for a very long time now. I do corporate trainings on the weekends, so I use an AWS account in order to do that. I will give you a very nice course today, guys. Please do ensure that you enroll into that course. It's free for the first 2 days of the month. It's really nice that I got this opportunity to do it on 3rd. I have just created the coupon code yesterday. Okay, so this is the AWS Management Console. This is how you will land in. You have so many different amazing articles covering all of the different services on the right side. You have all of the different product services listed over here. Don't worry if you spend 3 years or 3.5 years on this platform, you will be, amazed, and you will, fall in love with this platform. You literally know everything that is there to know about Amazon Web Services. You can always access the services from top by clicking on services. So that means a lot of college students generally ask me this question: do you require coding knowledge? If I ever told you that you need to know Java and Python before landing into Amazon Web Services, you would not like that answer. But again, really nice answer for you guys is you don't need to know coding in order to start working with AWS. But then if you do know coding, it's an added advantage. If you do know Python, if you know Ruby, or if you know Golang, it's an added advantage for you. You will be able to automate a lot of stuff. But then even if you don't know that, it's totally fine in order for you to get started. A lot of people ask the prerequisites, and only one prerequisite I tell them is you need to know how to do Linux-based commands. You need to know how to do subnetting, basics of networking, like whatever you studied in your third year of college in terms of your networking lectures, in terms of the OSI models and so on. Because I always believe that a person who knows basics of Linux commands and networking, they will be able to survive very easily with the cloud. They will be able to understand every concept in depth. I did start my career like that. I studied CCNA in my third year of college, and I was able to easily understand all of the networking concepts that AWS had in terms of VPC, or doing your VPN connections, or creating a BGP connection with your on-premise infrastructure and so on. Now let's take a look at all of the different regions. So you have the regions split up across the North America, the South America, as well as the Asia Pacific, Canada, Europe, and Middle East. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 5 over here, which means 20 regions for you to work with. So that means my slides were accurate. So you have 20 regions. 2 regions that are in China, you will not be able to see that over here. They have a separate logging, separate way for you to create an account. And then you have 2 regions for government cloud agencies that are being used by FBI agencies or Pentagon agencies, which you will not be able to take a look at over here. Okay. So these are the different regions. You will be able to take a look at the different availability zones. If you click on one of the regions and go to a service called as VPC, I will allow you to explore on all of that. So I'll probably wrap up over here. Thanks a lot for attending this session. We will move on to questions.